Hello, my name is Sarah, and today I'm going to show you how to transfer between two different scenes in Unity whenever you touch something in your scene. So for example, a door. You can easily modify this script to make it only work when you're pressing a certain button. You can make this script require you to have picked up a certain item so that you can maybe use a key. There's a lot of options that you could use, but I'm just going to show the very basics here in this tutorial, and that is how to create a door that takes you to a new level when you touch it. You just walk up to it and touch it. So before you start, you should already have a character that can move around your scene, whether that be a platformer style or a top-down style, it doesn't matter. And you should have two scenes created, one that you'll start in and one that you're attempting to go to. So in my example here, I have this platformer character, and he's actually using a Unity Playground script to move, but that doesn't matter. You don't need to be using a Unity Playground for this. In fact, we're designing this so that you're not having to use Unity Playground at all. You're going to be using custom scripts here, so don't worry about that. It doesn't matter how he moves, whatever your script, whatever your game does, that will work as long as your character can move around. I then have this very basic level set up. And also, this is level 1 that I have open right now. You can see in my hierarchy, it says level 1 there. I can also now, in my assets folder down here, you can see I have a scenes folder, and I have level 1 there, and I also have level 2. So I can double click level 2 to change between them. If you don't know how to create a new scene, all you have to do is go up into File, and you can do New Scene, or you can save your current scene as, and that will let you duplicate it, and you can edit the scene to make your second level however you would prefer to do it. Sometimes it's easier to edit an existing scene than it is to make a brand new one. But we're going to assume you've already done that. So if you haven't got two levels set up yet, and you're ready to transfer between the levels, then please pause the video and go get your second level set up, or at the very least create it. It's all right if it's not completely set up, but you need to have a level saved, a second level saved as a scene, in order to use the code that we're going to do in this script or in this tutorial. Okay, so I'm still back in level 1 here. Okay, but just, I have level 2 set up. It's basically the exact same scene for me, except for the border is gray stones instead of red bricks. But we'll go back to level 1 first, because obviously we want to start at the lower level, and then when we go through the door, we'll go to our higher level. So to start us off, we need a door. So this scene that I have here, I have a bunch of example graphics already, but hopefully you have some graphic in mind for what you want your door to look like. And I'm just going to drag this open door in, and I'm going to just drop it wherever I want the door to be. So you're just dragging the sprite in, and that will create your game object. Once you've done that, we need to actually create the door script. So let's create, if you don't already have a scripts folder in your project, make sure you create one. Keep your project tidy. Always keep your scripts in a scripts folder. And so once you've got your scripts folder, I'm going to right click my scripts folder and click create and C# script, and that will create the C# script inside my scripts folder. And I'm going to just call this script door, because that describes what it is. It's a door to a different level. You may call it whatever you like. You could call it portal if yours isn't just a door, it's a portal, a magical portal. You can click that. You can call it scene change. You can call it load level. You can call it whatever you like. As long as it is descriptive. Don't call it Bob. Right? Please don't do that. Call it something that describes what the script does, and that's the key to naming your scripts well. Okay, so I'm going to open up my door script in Visual Studio. And so I've got this door script here, and by default, of course, Unity puts this start and update functions in. We don't need start and update functions in this script, so we can just remove them. Make sure you still have your two curly brackets here, your one for opening and one for closing. And remember that everything inside a script, everything that will make your script work really needs to be inside these curly brackets, aside from the using statements. They're the only exception. They stay outside. But everything else is going to need to be inside these curly brackets, so make sure you don't accidentally delete them, and if you do, just add them back in. You always need these two curly brackets right after the line public class door : mono behavior, and that determines what is actually inside your script. Okay, so the first thing that we're going to need is a variable to hold the level that we're going to move to. So if we're going to move to a level, we want to be able to say what level that is, and we don't really want to say that in this script directly. Because what you really don't want is to have a separate script for every door in your game. Say you have 5 levels in the game, and 4 of them have a door that takes you to the next level. You don't want 4 different door scripts, door 1, door 2, door 3, door 4. That would be just annoying. Instead, we're going to have a public variable that we can set in Unity to change our door, what door our target is, our target level that we're trying to go to through this door. And you can think of it like that. This variable, again, as I've said before, is a container. A variable is a container for information. So we're going to create a container for some information, and in this case, that information is going to be a bit of text, the name of a scene, and it is going to be representing that scene that we're going to go to. All right, so to create a variable that's editable inside Unity, it needs to be public. So let's create a public variable here. And the type of variable, so remember the first thing you write is the access level, so whether it's public or private when you're writing a variable. The second thing that you write when you're writing a class-wide variable is the type. So every variable in Unity needs to have a type. They can't just be a generic box that you could put anything in. Unfortunately, it doesn't work that way. You need to have a type for what kind of things can go in that container of data. And in this case, like I said, we want to have the name of our scene. So that is text. So I'm going to go ahead and put a string type. So when we're talking about text, the type that you actually use is called string. And that's common in a lot of programming languages. So when you're talking about text, a bunch of letters added together, that is a string in programming. Okay, so public string, and then the last thing you put is the name. So we're going to call this level to load, and the type of capitalization that I'm using there is called camel case. So the L for level is lowercase. There are no underscores and definitely no spaces. You cannot have spaces in variable names. So each, to make it clear which, when there are new words coming up in the name of the variable, we capitalize the first letter of each of those words. So level, then capital T2 and capital L load. That's not required, but I highly recommend you use that convention for your variables, and it's very commonly used throughout the programming community. Okay, so this will create a variable in Unity that we can edit in the Unity editor. Whenever we attach this script to an object, to our door, we'll be able to edit that variable directly in Unity. So if we have this same script attached to multiple different doors, each one could go to a different level. So you could even use this to have a branching path where you've got your maze sort of level, and then they go one way, they end up in a completely different level than if they went a different direction. So you could actually use this to create branching paths in your game. Kind of fun. Okay, now this is a bit of information that we have created, a bit of data. And without having used that data, nothing's going to happen. So we need to actually use the data that we have created here. We've got this level to load. How do we use it? So first of all, we need to think about when we want to use it. Right? So you're going to have an action taken. We know that our action is going to be to load the level. That's the whole point of all of this. But when is it going to happen, and how do we make it happen in that situation specifically? And that is most of game programming. Almost everything in game programming consists of two things: what you want to do and when or how, what condition do you want to do it in. So what do you want to do? When do you want to do it? In this case, our what do you want to do is load the level, and our when do you want to do it is when the player touches the door. So there are two functions that are built into Unity that we could use here. That's on collision enter 2D and on trigger enter 2D. And well, how do we know which one to pick? On collision is for whenever you're colliding with something that's going to bounce you back off of it. So this could be when you're running into a wall, or maybe when you're running into an enemy, or anything that has, that will bounce you away. In this case, we don't really want our player to bounce away from the door. It's not really going to matter, but I'm going to choose on trigger enter to use in this case. But what that means is that one of the two things that touch each other has to be labeled as a trigger in their collider. And we'll get to that in a minute, but that's what on trigger enter means. So if your on trigger enter function isn't being called, the two things you need to check is A, do both of my objects have colliders? And B, is one of them marked a trigger? And is the other one marked not a trigger? And if that still isn't working, maybe check that a rigid body is attached to one of them. Okay, so at this point, we need to actually write the code though, because it's not going to work at all without the code. So the function that we're going to use is a built-in Unity function. And because it's built into Unity, you have to type it exactly correctly. Because if you don't, what you'll be doing is not an error, because what you'll be doing is defining your own function. Unfortunately, Unity doesn't give a crap about your own function. It will only call the specifically named function that it knows about. So you have to name it exactly the same way that I'm going to name mine here. A lot of times when you're writing your own personal functions, when you're writing your own variables, you don't have to match me exactly. But this is a different situation. This is a built-in function to Unity, this on trigger enter 2D. So you have to use the one that Unity uses. Okay, so I know I happen to have memorized what that is, but if you ever forgot, and often I do this, right, not for this function, but for many other Unity functions, I think, you know, I know this is a function in Unity, but I want to make sure I get it exactly right. I want to make sure that I get it exactly right. So if I'm going to do that, what I'll do here, I'm sorry, I'm just loading up a page over here for all of you to see. So what I would do is I would go into a web browser and I would type in something like Unity on trigger, and I wouldn't maybe not remember what anything else about it, or even just Unity trigger function. Right? I know it's something to do with the Unity. So not okay. There's on trigger stay. Oh, okay. So maybe I can find it from there. So if I click on trigger stay, I know that's not the right one that I wanted, so what else can I find? And you end up here with the Unity documentation. So then if I type in trigger up here, I can get a load of results from Unity, and I can try to find the one that I want. There's a lot here that maybe aren't what I'm interested in, but I can try trigger physics, or I can try trigger collisions, or collider. And you just need to get used to checking these things, okay? So I can see here, on trigger exit, on trigger stay. Maybe it's something like that, okay? So what we really want here is actually called on trigger enter. And there are two versions of this. One is on trigger enter, and one is on trigger enter 2D. And if you are using the physics system for a 2D game, you must use on trigger enter 2D, the 2D version of this function. If you try to use the 3D one, it will never be called because you don't have any 3D colliders attached to your object, and therefore the 3D version of the function will never occur. So there will never be a 3D collision, so it won't happen. So you need to use the 2D version of this function. So what I found here is the documentation for on trigger 2D, and you can see that it accepts a parameter. This function isn't just by itself, it doesn't just do something, it gets information from Unity. Unity gives us information whenever it calls this function. It says, yes, there was a trigger, it happened. Here is the thing that triggered the trigger. And that's important, we're going to use that. And then below here, you'll see in Unity's Unity will have an example of how this is used. So you can see down here that we have a on trigger enter being used down below. Okay, so it's very useful. So let's go ahead and go back to our code and try it out. Okay, so first of all, it's going to be a void function, and we can leave it as private. If we don't type anything, if we don't type either public or private here, it will be considered private, but you can leave it, you can type in private if you like, and that's the access level for the function. That determines whether something else can access it. Now it seems a bit weird that it would be private because, well, surely Unity needs to access it, but Unity is special, it can access it anyway. So private void, and let's call it on trigger enter 2D. Notice on, the O is capitalized, trigger, the T is capitalized. enter, the E is capitalized, and 2D, the D is capitalized. That's very important. If you're worried you might get it wrong, go to the documentation and copy it. It's absolutely okay to do that. I do it all the time to make sure I haven't made a mistake. Right? It's absolutely fine. Then we need to put in the parameter for this function. So remember that a parameter is just a variable that's being passed from whatever code is calling the function or making the function happen. It's passing that parameter in. So if I have Unity's code is saying a trigger happened, something ran into something else, it will then say, here is some extra information. So I've told you that the trigger has happened, but also here's some information about it. And that information in this case is it is the collider that hit this object. So your door script is going to be attached to your door. And your player or anything might bump into the door. And when that happens, Unity will say, oh, on trigger, enter 2D. And then it will say what it is that bumped into the door. So it will pass that information to your script. So your script will then on the door be like, okay, something's run into me. What do I do? And that's what we're going to write next. But we need to say what the parameter is going to be. And again, you can copy this. So in our documentation here, we see that it's a collider 2D. That's the type of variable that's going to be passed in. So in a parameter, you don't need to have an access type like public or private, but you do still need to say what type of variable it will be. And in this case, it's a collider 2D. And then we need to give it a name. So let's just call it other collider. Notice again, I've used camel case here, but the function itself is using something called Pascal case. It's very similar to camel case. The only difference is the first letter is capitalized. And in C#, it's very common for programmers to use Pascal case with the first letter capitalized for function names and also for class names. You notice that my door has a capital D. Okay. So then after I have written my parameters inside these parentheses, I need to add curly brackets. And if I add curly brackets here will dictate everything inside of them is part of the function. Okay, so your curly brackets are like borders and everything inside them is in function land and everything outside of them is outside. It's outside the borders. It's not part of the function. All right, so your curly brackets act like borders or cages, as I like to say for variables as well. They're an impassable border. Only certain things can pass the border. All right, so we now have a function. It's being called. Yay! To check if this function's actually working, let's add a debug log. So remember to add a debug log, you use the word debug with a capital D, and then a dot, full stop or period, and then log with a capital L, and then your parentheses, because log is a function, and so we need parentheses to indicate that it's a function, and we are passing information to this function. We're passing a parameter to it, and that parameter will be a message. So we're going to use quotes because this is text that we're passing to it, not the name of a variable, not data. It is text, so we're using quotes, and we're going to say exactly what we want it to log. And let's just say object hit the door and an exclamation point. And finally a semicolon at the end, because this is a line of code, we need a semicolon. All right, so all that was quite a lot of work, but let's find out if it actually worked. This is not going to load a level yet. All this is going to do is display a message when our player touches the door. It's important to test as you go like this, rather than waiting until you've written all of the code at once, because it's quite likely that there will be mistakes. I'm not saying that because you're bad. I'm saying that because everyone makes mistakes, even experienced programmers. What we learn to do as experienced programmers is write code in bite-sized chunks, test them out as we go, and fix mistakes as we go. And it makes us much smoother, because if you write the entire bit of code at once and then later try to test it out, you have a lot more space where there could be an error. You don't know what parts of the code work and what parts don't. If you test as you go, you know that parts of your code are much more likely to already work, and you can focus on the new parts of your code. That isn't to say that sometimes bugs won't crop up in the older code, but it's less likely. Okay, so let's try this out. Make sure you save your script. If you don't save it, it won't work. So make sure you save it. Remember, you can always tell if it's saved by the asterisk in the top of the script name up there. And there's none right now, so it's definitely saved. Go back to Unity. And if you should make sure your console window is visible. If it's not, go up to Window and choose General and choose Console, and then dock it somewhere where you can see, because when you're programming, it's very, very important that you can see your console window. Now, if any errors appear in this console window, you will need to make sure to fix them. You won't be able to attach your script to an object or play the game until the errors are fixed. All right, so if errors appear there, it will tell you exactly what's wrong, so read it carefully. It is using programmer speak, so it can be a little bit hard to understand when you're first starting out, but if you read it very carefully, see what it's actually saying, don't just ignore it because it's a scary message. Read it very carefully, and then look at what line number and what script it's telling you that there is a problem in. It will tell you exactly where the problem is. So I'm going to go ahead and make an error in my code so that you can see. I'm going to remove my semicolon and save it. If I go back to Unity, now there will be an error. Now this one here is a warning, this yellow one with a triangle symbol. That's a warning, and we can safely ignore it because right now it's just telling me there's different line endings and I do not care. So I'm going to just get rid of that one. But notice if I press clear, my error does not go away because it's important. I can't get rid of it, okay, by just clicking clear. It is important that I see this error. So it's telling me assets scripts door.cs. That's my script name, assets scripts door. And then it tells me a line number and a character number in the line. And then it says an error, CS1002. Well, that's not very helpful, is it? But it says semicolon expected. So if you see semicolon expected, it means you forgot to put in a semicolon. Now that's telling me that's on line 12. So if I double click that, it'll open Visual Studio to the line. Notice it's selected the line where the problem is. And usually you can tell what's going on because there'll be a red underline. And if you mouse over the red underline, it'll tell you exactly what the problem is. Here it's telling me semicolon expected. So the key thing here is do not just get scared of your error messages and give up. You need to read them carefully whenever they occur. Okay, great. That's working now. So what you need to do, make sure if you have fixed an error, you save it. Go back into Unity and the error should go away once it's been saved. Notice that I still have some errors, some warnings here, but that's from some other scripts that I have and it's not part of our issue just now. Okay, so now we need to attach our script because if I run the game right now and I walk my character over to that door, nothing is going to happen. That's actually for a variety of reasons, but one of the reasons is that our script is not actually in the scene. And if your script is not attached to something, it will not do anything. It has to be attached for it to do anything. So we have to attach our door script to the door, and it's very easy to do that. If you go down to your project window and drag your door script onto the door object in your hierarchy. So I'm dragging it onto the door object and dropping it. Once I've done that, if I look in my inspector, you'll see that the door has been added to the door object. Okay, so it's there. And notice that it has a level 2 load parameter or variable there that I can use. I can type into it if I want to. So I can say level 2, right? That's not going to work yet, but it's there because remember we haven't actually put in the stuff for it to work. Now, unfortunately, if I go ahead and run this, my character is still not going to hit my door. Nothing's going to happen. I won't get any message when they touch that door. And well, why isn't that happening? That's because I have not put on colliders. So in order for a collision or a trigger to be recognized in Unity, you need to have 2 colliders, one on each object. So my door needs a collider and my character needs a collider. That's required for any kind of collision to be registered. So let's start with the door. I have my door selected and I'm going to add a component and I'm going to choose a box collider 2D. So you can just type in box to the search bar here and make sure you choose the 2D version. And in my scene, you'll notice that a green outline has appeared around my door. Now, if you are doing a 3D game, of course, you can use the 3D version, but make sure you're changing your function to match accordingly. It shouldn't be 2D then. If you're using a 2D game, though, definitely use the 2D version for every kind of collider. If you don't like the box collider, you can use a circle collider, a capsule collider, a polygon collider, whatever you like, as long as it's a 2D version of the collider. Okay, so my door now has a collider, but that's not enough. The other thing I want to check on my door is because I've said specifically I want my door to register a trigger, not a collision. So I need to change my door to use the is trigger. So if I click on my door here, I'll go down to the box collider. I need to tick is trigger so that the door is now a trigger rather than a collision object. And that means the player and enemies and anything else can overlap with the door. And it will sense that overlap, but it won't prevent the thing from overlapping with it. It won't bounce it off like it would if it was a collision. So we're making our door a trigger. Now, this is still not enough because Unity can now tell how big the door is, but it doesn't know how big the player is in terms of a collision space. It doesn't know how big the player should be. So we need to add a collider to the player. So let's click on our player, wherever your player may be. Now your player may already have a collider on them. I'm assuming you maybe don't yet, so I'm going to add a collider to my player here. And it can be any type of collider you like. I favor capsule colliders for players. And the reason for that is that it prevents them from getting stuck on things, but it allows you to make them a little bit more human shaped. If your player is especially spherical, you can use a circle collider. If you want to just use a box, you can, and you can actually go for a polygon collider if you would prefer. But I think for most cases, a capsule collider is absolutely fine. I'm going to modify my capsule collider very slightly so that it's a little bit smaller and fits my character a little bit better, like so. All right, so my character now has a collider. So if I press play now, what I hope to actually happen is I will get a printout in my console window down here whenever I touch the doors. Let's see if that happens. Yay, object hit door. Fantastic. Okay, so we are now able to successfully sense when our player touches the door. Fantastic. Next step, we need to load the scene that we're trying to load. So let's go back to Visual Studio. And we need a new bit of code here. So we'll leave the object hit door login, or you can remove it if you want to. Or maybe you want to keep it, but you don't want it to show right now. If you want to do that, you can comment it out using 2 forward slashes. That changes it from being an instruction to the computer to being just a bit of information for the person reading the code. It won't do anything when the game is running whenever it's commented out like that. Okay, so now we need to add a bit of code, and it needs to be inside OnTriggerEnter2D. And we're going to add code to load our level. And to do that, we need to use the Unity Scene Manager. So the code for this would be scene manager, dot load level. But the problem is, you notice there's red underlines going on here, and it doesn't understand what a scene manager is. And that's because the scene manager, and I'm going to go ahead and delete this code for the moment, the scene manager is part of a subsection of Unity. So it's not part of the main Unity code. It's a subsection. And in order to use that section of Unity's code, we need to add a using statement, right? Okay, there we go, using statement up at the top. So up at the top of your code, after where it says using Unity Engine, make a new line and add using Unity Engine dot, and remember that dot means go to that thing and get something or do something. So we're going to the Unity Engine and we're getting the scene management library. So using Unity Engine dot scene management. Right, with that being used, we can now, inside our OnTriggerEnter2D function, we can now add scene manager, and notice it's now green, it's happier with me, dot load scene, and this is a function. So scene manager, go to the scene manager and do something, load the scene, and then inside these parentheses, we need to give that function some information, and that information is what scene should it load. Now, we don't want to tell it a specific scene because the person writing the code right now, you might not know exactly what scene yet needs to be loaded. And as I said, there may be multiple doors. So we are not going to use quotes and say level 2. That's the wrong way to go about doing this, because if you do it that way, you will need a separate door script for every single door, and that would be awful. So instead of level 2, we're going to remove that. Inside these parentheses, we're going to write in our variable. So it's like we're saying, okay, load scene, you're going to load the scene that is in this box. Here you go, have the box. So we're giving it whatever has been put into the level to load box. And remember, that is editable in Unity. So we will edit that on each door script. We can put a different level to load. Every time we, have this script attached to a different door, we can put in a different level to load in the little inspector in Unity. And whatever is in that box, that information is going to be passed to our load scene. So inside the parentheses, what you type is level to load, and you need to make sure that that matches your variable's name exactly. And if it doesn't, you'll get an error message. Finally, at the end, you need a semicolon. So we're almost done here. Control S to save your work so far and go back into Unity. Okay. So if you've done this properly, you should have no errors down here in your console log. If you do have any errors, pause the video now, go and fix them. Remember to read them carefully and check the line numbers. Double click to be taken to it in Visual Studio, right? It will take some practice to get used to those errors, but you'll get it eventually. Okay, so once you've got all your errors sorted, it's time to click on your door open. And your door open will have your door script on it, and mine's called door open. Your might not be called door open. Your door, whatever it's called, your door. Go to your script on that door. You'll see in your inspector your door script, and look where it says level to load. And what you want to type in there is the exact name of your second level. So mine is called level with a capital L space 2. You can call yours whatever you like. It is allowed to have spaces. This one is allowed to have spaces and capitals and numbers and whatever you like. All right. Same as any file names. You can't have some things, but you can have anything that a file name can usually have. You can have here. So mine's level capital L space 2. Make sure it matches exactly. Punctuation, capitalization, spaces, everything has to be exact. Okay. Once you've got that, if you press play, this still isn't going to work. I'll just tell you right now, but you will see something different. So once you press play and you walk over to your door, you'll get an error message. So let's practice. We're going to read this error message very carefully. So it says, scene level 2 couldn't be loaded because it had not been added to the build settings in the asset bundle. To add a scene to the build settings, use the menu File, Build Settings. Okay, so that's pretty clear. Unity is being actually quite helpful in this case. Some of the error messages are not very helpful. But this is telling me specifically the scene that I'm trying to load, which it tells me what scene it was, level 2, couldn't be loaded because it's not in the build settings. So what are the build settings? Ooh. Well, then it tells you exactly how to access the build settings. And it tells you can add the scene there. It doesn't tell you how, but it tells you can add scenes there. Okay, well, let's do that. So it said to go File, Build Settings. Let's go up to File, Build Settings. And now I have some scenes already here, but yours won't look like this. Yours will look, I'm just going to remove those. Yours will look blank. Okay, by default, yours will look blank. And to add a scene to it, you can add the scene that is currently open by clicking Add Open Scene. That's fine, but it's a bit of a pain to open each scene and then click Add Open Scene. That's annoying. So it's a lot easier to, with this build settings window open, go to your project, choose the scenes that you want to be added to the build settings, and drag them in. Now, eventually you want every scene that is actually going to be displayed in your game needs to be in the build settings, because this is how Unity determines what actually goes into the final EXE or whatever type of build your game's going to have. If you're making it for Android, it would be an APK. If you're making it for web, it will be your HTML zip, right? So you need to have every scene that you actually want to go into your final game. It needs to be in these the build settings here. They also need to be in order. Most importantly, the rest of the order doesn't matter too much, but it's very important that they be the first scene at the very top of the list is the scene that you actually want to load first when your game first starts up. So for now, I'm going to leave level 1 there, and I'll have level 2 be next. All right, so far so good. So so that's actually great. So if I just close this now, and I press play, and I walk over to my door, I think it should actually finally work. Yes. So when I walk to my door there, it worked fine. Make sure if you have, we're working on the build settings and you pressed build, click cancel because you do not want to wait for it to build. There's no point right now. Building a game takes quite a while. That'll create the EXE for your game, or as I said, whatever type of platform you're on, it will create the final version for that platform. Don't worry about that right now because that will take a lot of time and it won't be worth it for the moment. Right? So instead, you can just close this. It will save automatically. So if you did click build, click cancel. You don't want to wait for that to build. Okay, anyway, test your game after you've added those to the build settings and see if it works. Once you have tested it, so if you haven't done that yet, pause it, go try it out. Once you've tested your game to see if it works, and it has worked, the last thing we need to do is add a bit of a check into our script. Because what you don't want to have happen, say you have enemies in the game, and an enemy wanders over to the door and touches it. What do you think will happen at this stage? Right? Let's look at our code. Our code says on trigger enter other collider, and we don't care what that collider is. We just immediately load the next level. On trigger enter will happen if anything touches our door. So if a bullet touches our door, if an enemy touches our door, if a little bird touches our door, whatever touches the door, it's gonna load the next scene. And that might be really not what you want, right? You don't want an enemy to trigger a scene change when your player is halfway across the map. Absolutely not what you want. So we need to check that the other collider is actually the player. So how do we do that? Well, what we'll use is something called a tag. So let's use our other collider, and I'm going to copy it because we're going to use this exact variable. We've been given information by Unity. We need to use that information. So Unity has told us in this function, it's told us what it was that collided with us. And we can get lots of information about that other object, what it was that collided. So the easiest way to check if the thing that collided with us is a player is by making a player tag. Every game object in Unity can have a single tag, and that tag can be defined by you, by the programmer. And you can say, you can make it anything you want, and it will be a single word, right, or a single string of text. So in this case, we're going to assume that our player will have the tag player, and I'll show you how to add that tag to the player in a moment. So in order to check if that other object that collided with us has that tag, all we need is a very simple if statement. So remember that if statements in C# are written as if space, and then we have some parentheses. And inside the parentheses, we put the question, the condition. What has to be true for this if statement to occur? So in this case, the thing that has to be true for our if statement to occur is that the tag on the other collider has to be player. So we're going to check other collider dot tag, and remember the dot means go to that thing. So other collider, go to the other collider and check the tag on it. And then we're going to do an equals equals. That is a check. So an equals equals, two equal signs, means check if this is equal. It doesn't mean make it equal. That's what a single equal sign says. Single equal sign is an action. It's a command. Double equals is a question. It's saying, are these two things equal, true or false? So remember that. Single equals is a command, double equals is a question. So we're going to question, is the tag equal to some word that we're going to define. And that word is going to be in quotes here because we're going to write the word directly into the code. If you're writing a word directly into the code, you use your quotes. So I'm going to check if the thing that we have hit has the player tag, and I'm going to capitalize that P because tags in Unity usually are capitalized. It's just a common convention. You don't have to do it. You can use any word you want there, but you should use the word player, and I would recommend it be capitalized. Okay, so that's our question. Is the tag on our collider equal to player? And if that is true, then after our question here, after the closing parenthesis, we're going to add some curly brackets. And so our if statement is saying if everything inside these parentheses is true, then everything inside these curly brackets will happen. And only if the things inside those parentheses are true will the things inside these curly brackets happen. So it's if this question is true, these things will happen. So what we want to put inside those curly brackets, well, it's the code that we had right below. So we're going to actually remove the code from below, this scene manager.load scene. I'm going to use Control X to copy it and Control V inside this second set of curly brackets to paste it. So be careful now because we have a lot of curly brackets, and when you're first starting out programming, it can be really confusing. You want to make sure you're using your indentation to help. Make sure your indentation looks like mine, okay? You want to have your outer curly brackets for the entire script are way out here. Then you have these curly brackets, that's for everything that's inside your function, which happens whenever something enters the trigger. And then you have these inner curly brackets for when something is the correct tag, okay? So make sure you have things in the right place. Double check your curly brackets because it can be a bit confusing if you're not careful. Okay, this is the code we need. That's all we need. It's all done. So let's save that and go back to Unity. Now, if you try to play the game right now, yours probably won't work because your player is most likely not yet tagged a player. So let's go to our player and click on them. Okay, so you will notice on my player, sorry, my mouth is getting dry. You will notice on your player, you have a, if you click on them and go to the inspector, at the very top of the inspector, underneath the name of the player, you'll have a tag. Now yours might look a little bit different than mine because I have Unity Playground turned on. So I'm going to go ahead and turn that off because it might look a little bit funny for you. It'll take a minute to reset. There we go. So let's just try clicking away and coming back. There we go. So this is what yours will normally look like. You will have at the top, you will have tag player, and you'll have something called a layer. We're going to ignore that for now, but tag. Now yours won't say player, yours will probably say untagged. Okay, so if you have your player selected, it'll say tag untagged. Now, if you click on that untagged, you'll get a drop-down menu. Your drop-down menu will have a lot less things than mine does because mine has my project already has some tags set up. But yours probably won't have a player tag. By default, it won't be there. So we need to add that tag. So if you click on that drop-down and you go down to add tag, you'll get a list. Now your list will be empty. It won't have a bunch of things in it already, but it will be this, it'll have a white box there. And there'll be a plus sign in the bottom right corner. And if you click that plus sign, you'll get a new tag and you can add the tag in. Be very careful with the names that you give this tag. It has to match the name you put into the code exactly, just like we talked about before with the scene. It has to match both the spelling, the capitalization, any spaces or punctuation, they have to match exactly. It's very important. Or your computer just will think it's a different tag. It thought, oh, well, you wanted to have a tag called player with a lowercase p. That's what you wanted. And the thing doesn't have that tag. So, so you need to be really, really careful. In my case, I capitalized the P for player. And I typed it was just the word player with a capital P. So I would recommend you use that. So you would type in capital P player, and then you'd hit save. Now I'm not going to do that for mine. I'm not going to do anything because mine already has a player tag. And yours might actually as well. It might be built into Unity. And if it is, then you don't have to change anything. You can just use the one that's already there, and that's absolutely fine. Okay, but if you did later want to add a different tag, that's how you'd go about doing it. Okay, so once your player has the player tag on them, your script will now work again. So if you press play and you go and try to run into the door, we should see it take you to the other level. If it doesn't, if it gives you an error, make sure you go and check your console log, carefully read the error, and try to figure out what to do to fix it. If you double click on it, it will take you to the point in the code where the problem is. All right. That's pretty much everything there is to do for changing a scene. You can still use this exact same method for changing the scene, but you can change the conditions to do it in a different way. So say you wanted to change the scene whenever you killed a certain number of enemies. You would simply change the condition. So really you can think of everything in game programming as a condition and an action. So our condition is in this case is when the player specifically touches the door. That's our condition. And our action is to load the scene that we've stated, that we've put into the box, right? The scene that we've put into that parameter. If we want something different to happen, we could have the same condition when the player touches the door, but we could change the action. So you can separate those two concepts out. You've got a condition and you've got an action. And that can often really help you when you're trying to figure out what code to write or how you can use things you've used previously. So in this case, you could use the ability to change a scene. You could make that happen when you kill all the enemies, or you could make it happen when the player is killed. You could make it go to a game over screen or something like that. So there's a lot you can do with what you've learned today, and I hope that it was helpful. If you have any questions, please ask in the comments below, and I hope that this was useful to you, and I hope that you will continue watching future videos. Thank you. Bye.